Thank you for tuning in to our presentation on plasma cutting. I'm John with Forest Scientific, and this is our new logo. I'm sure you've seen our old logo. It said Forest Scientific, kind of a square-looking logo. We've updated our look for modern times, and most people say I have a Forest CNC, so it's really more descriptive of what we actually offer. So this is an introduction to plasma cutting. And plasma cutting is really a growing area. It's used in ag, it's used in welding programs, it's used in HVAC. And we're going to show you several different things and show you application as well as some of the fun and artsy types of things. So like, for instance, this is a simple welcome sign. And the part could be easily imported from Google. You can actually go from a Google image to a part in a matter of a couple of minutes. And we teach you how to weld the drawing together. This is actually a fairly simple project. This one here, you can see that they did the cutout. Really nice cut quality. You can barely tell where it was started. And actually, you can take your fingernail and just knock that blow up off of where it did the initial pierce. Looks like another pierce point here. You can tell where they're at, but they're fairly fine. And more than likely, this wasn't done with fine cut consumables because it's even finer in most cases if it is. And here, they left a little bridge here to keep this piece in. One thing that's important in a plasma torch is a really good torch height systems. And we have a automatic torch height system that's second to none. I like to brag about it by showing you this video. And the reason it's important is when the metal is heating from the cutting process, it'll tend to warp. Now, it generally, I've never seen metal warp this much, but if it can do this, it can certainly account for the smaller variances from the cutting process. So this is to show you how severe it can actually be, and yet it will keep up with it. Little blow off because of the varied height, but that will actually knock off very easily, and it didn't crash. The other reason why it's so important is you don't want the tip to touch the metal because it'll shorten your life of your tips, and sometimes it'll actually put the flame out. So to keep it moving and to have the best possible quality and a long life of the consumables, an automatic type torch height system is crucial. This is the converter table. We're the only company that has a product like this because it's completely a router and completely a plasma cutter. And so it has a routing table that actually allows you to hold the wood in place, and it seals the water bed. And it's about a 10-minute conversion to go from a wood router to a plasma cutter. And you take the wood table off, and then wood cutting table off, and switch out the router head for the torch, and you're ready to run in plasma mode. This is often used in schools that don't have enough space for two machines, or maybe the budget's tight, so someone will start off with this and then they'll add a router later on. Or maybe it's like Alaska where it costs so much to get it up there and then the classrooms are smaller just because of the cost of building construction in that part of the world. A lot of schools will want to have an actual separate router if you're going to be doing a lot of cabinet making, because we don't offer a vacuum table on this type of unit. It's only a clamping system, and it's always best to have a vacuum table for a router that's going to be doing cabinet making. But this gives someone an option to start off with the capabilities of both machines if the budget doesn't allow for both machines, and then leave it as a plasma cutter and add a router later on. We try to be best in class. Actually, we don't try to be. We are best in class at each price point. And so this competes with machines that are in the $10,000 range. And this is an actual complete turnkey package. So for the size, I believe the 4x2 starts around 10,000. The 4x4 is a little bit more. And that's including the plasma torch, the computer, inside delivery. We have a automatic torch height system included, a breakaway system where most $10,000 machines would be a box of parts that you have to assemble. You add another $3,000 for a plasma torch, and if you didn't budget that in the upfront picture, maybe a year or two before you get your box of parts put together and actually able to do something. And another $1,000 for a computer. A torch height system is generally $2,000 to $3,000, and most of the ones in this price class don't even have a breakaway system. So this is a huge advantage, and it's an actual working machine with success from day one because of the on-site training. The next level up is the Titan. This one and the FAB-Bot on the previous page are built with structural aluminum, and structural aluminum is significantly stronger than those built with bent sheet metal. Bent sheet metal, you can flex it and get it out of kilter and it won't work. Where with this construction, it's strong and rigid like our welded steel machines, but it's lighter so that way you can get it upstairs if you have a lab on a second floor instead of on ground floor. You can save a little money because aluminum is cheaper than the steel. But it's not giving up capabilities. This one can do anything that's on the next slide, but the one on the next slide, and this one does have a water table in it. The next slide is all welded steel construction, so it's built like a tank. And the higher Aerostem model is the HS series. It's even heavier duty steel construction, and it also uses closed loop servo motors versus these stepper motors on the lower costing models. I'd love for everyone to have this model because it is the very best. However, anything that can be made on this can be made on even the entry-level machines. Might be a little bit slower, but anything could be done on each level. No one's ever been disappointed for going higher. And we also offer a trade-in program so that, say for instance, you are in a tight budget, you could start off with a lower-end model, and then if you purchase a higher-end model within the first year, we actually give you 100% credit of the purchase price to upgrade it to a higher-end machine as time goes on. So you're not stuck with a box of parts without all the other parts you need. It's sitting there for years until you can put it all together. You actually can start off with something and make it usable. We have various advantages. Number one, we have been around for a very long time. Most of our competition has not been making CNC machines for over 31 years. And so we have experience and longevity of being around for a long time. Our machines come fully assembled. If you buy a box of parts, I don't know of a teacher that has a lot of extra time. It's just teaching is a very demanding job that often your evenings and weekends are already spent doing things for your classes, who can add an extra 40, 80 hours to build a machine. So our machines come fully assembled and you receive on-site training. You're not having to sit there trying to figure it out on your own. We'll teach you, and we'd like to teach at least 2 of your students so that you can be successful from the first day. We have superior technology, and it's just not a blank statement, but we not only have the longevity of over 31 years of experience, but we, in addition to building new machines, we rebuild every other brand. So we know what's good and what's weak in every machine on the market. And we take that back into our designs to have a superior design that is not only reliable, but easy to use. Because if it's not easy to use, you're not going to get as much use out of it. They're also all built on industry standards and using industry standard codes, so none of them are using a proprietary system. And we have the best warranty in the industry. We have a 3-year on-site parts and labor warranty that covers all the parts, including the plasma cutter, the computer. We don't send you out to our parts suppliers for a warranty claim. We cover it all ourselves. And we have a lifetime unlimited phone and internet-based tech support. And it's nearly 24/7. I'll get a phone call from somebody that is getting ready for a competition, and under the stress of getting ready for the competition, they might forget something, and they'll give me a quick call, and I'll say, hey, this is how you do it, and they're back up and running in minutes. And that's a great service to be able to get help when you need it. We were featured on Mythbusters Junior. So if you go back to the previous season, you will see our routers and plasma cutters not only making parts to bust myths, but a lot of the props on the set were also made on our machines. The following videos, portion of the video is going to cover using en route, which is an industry standard package that has 85% market share in industry that's actually made for plasma cutting, and also our HVAC software. And we're using the industry standard software called Shop Data for that. And you'll be able to see how you can go from matching up pictures in a screen, sizing it up, and then going to a finished product. So stay tuned. We recommend using en route for plasma cutting. There's a version that is just for woodworking, and then there's a version that is for plasma cutting, and we have a combined version. So that way, if you have a CAD lab of, say, 50 stations, you can have one lab doing plasma and routing. Most wood routing softwares and milling softwares don't really handle things specifically for plasma cutting, which you'll see some of the advantages. So like, for instance, if I'm just going to draw a simple rectangle, I can draw this rectangle, and I can select engraving, which engrave, when we're using plasma, is just telling it that it's going to be the center of the cutter on the center line versus actually engraving. Although it is possible to do an engrave. This time we're just cutting center of the line. What I'm going to do is select a strategy. I'm going to say 12 gauge steel, hit OK, and that actually generated my tool path that I can cut this out. I can also, instead of cutting right on the line, I just hit this button to delete the toolpath I just made. I can do a kerf compensation. So if I click on kerf comp, I can select, say again, 12 gauge steel. I can come in and tell it I want to have a lead in. I can set the angle of my lead in and hit OK. Now, for full disclosure, I'm going through this pretty fast. When you get a machine, we actually come in, set it for you, teach you how to run it. We go quite a bit slower because we want you to actually do it and make sure you really know it. We're really on a very short period of time, so I'm trying to cram more than we can actually fit into the time period. So anyway, I'm going to edit my entry exit, and I can actually turn this lead in line so it's here. And notice these little errors, that's the direction I cut, so it starts off the part and comes off. Another way that we could cut out this exact same piece, and I'm going to delete this toolpath, would be to do a kerf compensation, but instead of doing a lead in on the line like that and staying right on the line, we could do a loop corner. And I'm going to give it a 1/2 inch offset and hit OK. So with plasma cutting, the plasma cutter is very greedy. And if you slow down to go around this corner, it may round the edges a little bit because it's always trying to get as much material as possible. And so this feature takes it off while it's going in and out, because even if you're driving a Ferrari, you can't make a turn without slowing down to make that turn. So what this does is it loops off and then loops back on, so that way all of the accelerating, decelerating is out here, just like the car going too fast. And then when it gets back to this point, it's in the straightaway and continues on, slows down, makes that turn, slows down, makes that turn, and continues on. Now in this case, it's starting here, so I want to change this starting point as well. So I'm going to hit Edit, Entry, Exit, just drag this over, and then right-click, Exit this tool. And so from here, you can cut on the line, you can cut beside the line, you can loop off the edges of the lines to get the very best of cut. A lot of things, a very common project in most schools is signage. And so if we go to A for text, and we come, say, to here, and I'll just type ABC, notice that these are a stencil-like font specifically made for plasma cutting. As far as I know, no one else has a font like that. And you can also go in and very easily create your own fonts by altering the letters, which is what most people have to do. So if we wanted to, we could just do some edit, trim and extend, and cut out and modify any font to be able to work for this machine. So right now I'm going to just cut on the line. So I'm going to click Engrave, select my steel thickness, 12 gauge steel, hit OK. And again, you see these arrows. Now, little tip, toolpath, edit, entry, exit. If you're starting a line, you may see a little divot. But if we come into this little corner and do an inside corner, very rarely will you really see it, especially if we're using fine cut consumables. So I'd like to mention the consumables. With a PowerMax 45, which I consider the most ideal for most schools, because most schools are only cutting 1/4 inch and below. Now, if you're going to be cutting thicker materials, you can go up to an 85 amp torch or even larger. But since the vast majority of schools may be 3/8 and under, I don't recommend oversizing your torch. You're better off having a torch that's in the sweet spot. So if you have a 45 amp torch, you can do up to 1/2 inch thick. But the sweet spot is really, that 1/4 inch and below, and you can use these fine cut consumables. They'll actually give you a laser-like cut quality. And not only can we do letters and things like this, but we can also bring in things from Google. So if I go into Internet Explorer, I could do a little search, or maybe Chrome, whichever browser you like. I could do a little search and download a piece. So I have pre-downloaded some objects. And so what I'm going to do is bring in this cactus. And with this cactus, I'm just going to hold down my Shift key and bring it down a little bit. And oops, I resized it a little bit too fast there. And all I have to do is click on this option here, and it will convert this raster image into a vector image. And so what I'm going to do now is go to Transform and Ungroup. And I want to get rid of this right here. But I don't like this little divot here. So what I'm going to do now is edit this curve. And I can quickly come in. I think I'll just delete this little point. I'm going to zoom in so I can see what I'm doing a little better. I'm going to delete this point. And then I'm just going to click here and drag this up. Yeah, looks like I need to get rid of a couple more points here. And now I've edited the artwork that was less than ideal that I grabbed from online, and made up for it. And let's go to one more point. Probably get by without it. And now it has the nice curve that we actually want. So we start off with this with something written on it. And now we have a cactus that we can cut out. And so again, if we want to cut it out, we just click on engrave, select our thickness. And again, it's not engraving, it's just that the center of the cutter is following the center of the line. And again, I'd like to hide this in here. Toolpath, edit, entry, exit. I'm just going to drag it into this inside corner. Right click, exit this tool. And then all I have to do is go to machining, output to file, and that'll create the industry standard G&M codes to actually make this part. Now we're going to switch from en route to the HVAC project. So you can see a complete project that isn't just a sign going from beginning all the way to a completely assembled part.
Make sure you're on your fitting tab. Go to add an item. And we're looking, I know it's fitting number 4. But if you didn't know, you can scroll through, this one should be able to reduce. If not, there should be another one that actually reduces. But I'm pretty sure that one does. So you just double click on the image. It'll prompt you here for your size. How big are we making this?
6.
So 6 there. This would be the back side.
The depth is 4.
It's going to go to the top here.
4.
Reducing 4 to 4.
And 4 inch.
Yep. The connector at the bottom would be the...
It's a 1 inch flange with a 1/2 inch half. So the allowance would be 1 1/2 total. With no relief angle.
So that'd be 1 1/4, 1 1/2 flange out.
Yep.
And then the top would be a slip and drive.
Yes.
Alright. Straight at the bottom.
None.
Straight at the top.
None.
Throat radius.
6 inch.
Okay. Centered elevation. Which would be, that just means that it's not going up or down or, yeah.
0.
And then degree, 90. Alright. We're going to make one of these, I assume.
1.
No liner.
No liner.
So that would be your installation. Fitting seams, small Pittsburghs.
Small Pittsburgh.
Okay. Throat seam.
Small Pittsburgh.
And then if we were to have to chop this, it would be the standing seam.
Right.
Okay. Material, what?
26 gauge galvanized.
26. And then the same sheet size, 96 by 48.
Correct.
If that all works okay, everybody's happy with that, we would go to save. It'll generate your 2D images here and your 3D images here. Then we would go to nest settings, tell it we want to nest all of them, just the one. We would change the sheet size back because it remembers what you used last. If that's all okay there, go down to nest. And you have your one sheet. It's only using about 14 inches by the 48 long. So then it would actually just trim off that excess, and we'll watch it do that there. If that looks okay to you, if you're happy with that, you would post it. Make sure your path is correct. Make sure, again, your amperage is correct and your gas is correct. And then here, same thing, just reports, nest summary. Your summary and your labels you have to do after you've posted it. If you do it before you've posted it, you won't get any information as far as the sizing, the material, or the image there. Print. And save that under I want to call this reducer or reducing elbow.
Yes, that's fine.
Then you have your plasma labels. And same thing, you just print, okay. And since we have that directory there, we just click on that and just add labels. And that's your process.
90-degree fitting right out of the CAD/CAM software, and the solid lines are cutting movements, the dash lines are rapid movements, then it actually shears the piece off at the end. And so now we're going to hit the green button for play, and the machine will begin moving. So right now it's moving over. It's set up to automatically sense the height of the material, and then begin cutting. And since it's a very thin gauge of metal, there is some warpage. The height is constantly changing. So the automatic torch height system of the machine is making up for it so it doesn't crash into the metal as it's constantly changing. The machine is also automatically setting the voltage when it first starts cutting to be the correct voltage to maintain the correct height in making these parts. Now I'm simply shearing the metal off. Yeah, we'll keep this to cut later. Go. This work the can tech. All of these parts were just caught on the plasma cutter using the CAD/CAM software. And now we're going to put this 90-degree angle together. Mr. Andrews is going to demonstrate this whole process.
I'm going to start by just applying scribe lines to one of my connector ends. What we have here is we have on the small end of this reducing elbow, we have a slip and drive connector end. And on the opposite side, on the larger connector end, we have a flange and a hem. So I'm just going to apply some scribe lines so I know where to bend my pieces in the processing. We're going to have a 1-inch flange with a 1/2-inch hem. So there again, I'm just applying some scribe lines to this connector end. I know I have the inside of my fitting because I marked it with a Sharpie. Hopefully in the future we will have tags to apply to these fittings, as many fabrication shops have. At this point, I'm going to go over to one of my edging machines, and I am going to apply an edge or a flange to my two cheeks here. So we're going to head over this way. Okay, now we're at our easy edging machine. We're going to apply the flange to both the throat and the heel of this cheek with the easy edger. So very carefully, we're going to roll this throat. I always like to apply or go through the machine twice, just to ensure we get a nice square edge on our cheek. As you can see, the second time around is a little easier, and it will flatten any deviation in this flange. You can see we have a real nice smooth flange here on this cheek. my second time through. Here again, that's the finished flange on each cheek. Okay, at this point, we have our throw and our heel. We need to apply our pocket, our Pittsburgh pocket, to both pieces. So I'm going to insert into the Pittsburgh lock forming machine. Then we're going to spin our parts, feed them back in. And this offset a little bit on this connector end that is going to have the flange and the hem. It just flattens everything out just a little bit and makes it a little bit easier to fold in the bar folder for our hem and flange. Now we're going to insert some strips of metal into the Pittsburgh pocket. This allows us to roll our throat and heel into slip rolls without crushing this pocket. So we're going to head over there right now. Go. Okay, so now we're at the bar folder. I'm going to apply the hem to each piece before I proceed into the slip rolls. I feel it's a better time to do this in the fabrication process. I already have it set at a 1/2 inch because this fitting requires a 1/2 inch hem to the outside. So I'm going to do that 4 times. The throat and heel I just completed. Now I'm going to do both cheeks. And there's our 1/2 inch hem for this connector end. Okay, so now we're at our set slip rolls. We're going to form our throat and our heel to the certain radiuses that we have here on our cheek. I'm going to use my cheek as my template because these parts have to fit on here, so there's no better template to use than the actual piece that you have. And be sure to make sure you roll these in the appropriate manner, so we don't end up with the outside of the part on the inside. So we're just going to make some small adjustments here and roll our throat. And we're going to see how this fits up to our cheek just by moving it up to there. And you can see I'm really close there. I think that's a good start for this particular part. I will lower this back roll so I don't get quite a tight radius as I did with the throat. The heel will have a larger radius, and we're not rolling all the way through. We have a little bit of straight here on this small connector end, actually 2 inches of straight. So it's not a continuous roll. So I will start with the end, the larger end, and I'm going to stop here on my mark, and then I'm going to check this and see how well it fits up to my throat, or my cheek rather. And you can see I'm a little tight, but that's just going to be fine. I will just work this a little bit out by hand, and I can get this to fit quite nicely on the cheeks. Yeah? At this point, we have everything formed and rolled to where we need it. I'm going to finish my connector end with the flange and the hem on it on this box or pan brake. Very convenient way to do this. Just put your piece in, clamp it on your mark, and we're going to come up 90 degrees. Like so. We're We're going to do this 4 times. And you can see, as I did earlier, I flattened these flanges out just a little bit. This allows me to get in and bend in the appropriate location. After I bend these flanges up 90 degrees, I will fold these back down. You'll never know that we unfolded them to do this process, because this will end up in the pocket of the Pittsburgh block. At this point, my connector end is complete with the 1-inch flange and 1/2-inch hem on it. As I said earlier, we're just going to straighten these out, and then we're ready for assembly of this reducing elbow. Okay, so we're back. We're finally in our final stage of fabricating this 90-degree reducing elbow. We have all our connector ends done and complete, except for bending the drives. We'll do that after. But our pieces are already bent and rolled, and I'm going to start with assembly. I always encourage my students when we start to assemble fittings that starting on working our way from one end of the fitting out. And that's difficult at times because when you spin the fitting to put the other cheek on, usually we work from one side, from the right side to the left, or the left side to the right. So that's one common thing I try to tell my students is always start on one end, even though it might be awkward working opposite direction. The reason I have them do this is it will enable the part to be nice and straight, and if there's any deviation in the part, it will not twist, or as we call in the sheet metal trade, rack. So that's a good habit I try to instill into my students. As I start, I also use this. This is a setting tool for a lock, a pipe lock, or a hammer groove lock, actually. This does work well for getting the flange into the pocket of the Pittsburgh. Even though that's not its intended use, it's a very useful tool for doing such thing. So I'm just going to take some pieces and tack this, if you will, in a few locations. See how it's up against my body. Here again, this stops a lot of the bouncing and movement of the fitting. Having it secured and in a stable spot, and you can see how that finishes. So far, this connector end is fitting up quite nicely. So we have this on. I'm going to continue with my other cheek. And there again, I'm starting in the opposite direction. Using my hammer lock or my tool to help me get the flange in the pocket. And there again, whenever assembling something with a flange, we always want this flange to be to the outside of the bend. I've noticed in the past that when students, or anybody for that fact, assemble this, sometimes it tends to distort or crush these ends. So another tip as far as fabrication, I'm going to finish with the throat. Once I get it caught, you can see how if you take your time and roll this correctly, it will fit in quite nicely. Have to make a small little modification here. Have a set of pliers nearby just in case you have to make any small adjustments. Handy tool, another useful too is a screwdriver in case one of the sections in the pocket closes up. This is a handy tool just to open that up just a little bit. And we're going to make sure we're nice and flush here using the side of the hammer. Now that I have this assembled, I'm going to give it a good look over. Make sure everything looks correct. Make sure everything looks flush. I will make some small adjustments for this flange after I'm done hammering the Pittsburgh lock, making sure it's nice and flat. And at the end, I will bend the 1/2-inch drives on this for a connector end. If we were to attach another piece of this, we need our slip and drive connector end. So at this point, everything looks good. I'm going to continue hammering this Pittsburgh lock, get it nice and tight and as smooth as possible, and this will be a completed fitting. Okay, so our fitting is all assembled, hammered together. Pittsburgh lock is nice and smooth. Our final step is to bend the 1/2-inch drives on this particular piece. So we put it, this is made specifically for that task, and we're going to bend the cheeks on this particular part. Now this fitting is ready for installation. We have a nice flat flange here. If this was going on a surface where we could screw it in, we could use some sealer and screw it to that surface. And on the small end, we're ready to connect a slip and drive connector end to here, whatever that fitting or piece of duct may be.